So talking about limit graphs, graphs of limits. So when we're talking about a graph of limit, we're pretty much saying, again, like we said, what does it look like? And the limit as x approaches, let's say 0 here for the graph, what does it look like? Well, if this is my graph, f of x, oops, f of x, at 0, what does it look like? The y value looks like it's going to be 0. So if you're given a graph, a limit for the most part is what's the point there? And for 99.9% of life, it's always just the point there. If I give you guys another question, if I say, hey, if this is 1 and this is 2, what is the limit as x approaches 1 of the function? Well, that point now is 2. Now, a big deal for us is to say a limit only exists if it approaches a number from both directions, but that they both agree upon. Like as my example with a monk yesterday, did the 3 monks have a clue what an elephant looked like? Remember, one said it was a hose, one said it was a tree, one said it was a rope. They had no consensus. Right? Imagine if you guys never met me and you guys said, oh, Mr. Ko is, one person says Mr. Ko is a short, let's say Filipino guy. And then one person says Mr. Ko is a dark Indian guy. And one person says Mr. Ko is, I'm trying to describe teachers, a tall Korean guy. I guess which one would be the closest? Tall Korean? I'm not even Korean. Okay? So what would it look like? It will have to look like everyone would have to have the same consensus. Now, points that don't have limits, if I draw a graph, and then I'm going to draw this here. It's 1, and draw this as 2. Okay, and x is 1. The limit as x approaches 1 of f of x here, as we get closer to 1, from not one side, from both sides, from the left side and the right side. Well, the left side says, hey, at 1, so we're going to denote this using what we call one-sided limits. So one-sided limits means specifically from the left or right. So from the left side here, it looks like I'm approaching 1. So we denote that by the limit as x approaches 1. And if you notice this, please take a notice. There's a little negative sign in the exponent position. It's not really the exponent. It allows us to say left. Unless if you want to write all the time, let's want to write limit as x approaches 1 and write left there every single time, which math people, the point about when writing things in like a mathematical notation is to save us a lot of time. So we never write this. We just do a little negative sign of f of x. So what does the graph look like from that left side we said? As we get closer and closer to 1, as we sneak up, as we ninja moves to 1, the y value looks like
1.
1. Thank you. 1. That's it. Sure. From the right side, let's write that in red. The limit as x approaches 1 from the right side, f of x. So I'm coming over here like a ninja on the right side. What does the y value look like I'm getting closer to when x is 1?
2.
2. Now, does 1 and 2 agree? Like, again, you're trying to meet someone for the first time. You have 2 friends that says, hey, the guy's tall. The other person says the guy's short. Do they agree? Nope. So you can't tell me what it looks like. So there's no limit because both sides don't agree. So why is that important? Why is it important for me to be able to talk about left and right side? Because for problems that actually agree, okay, very similar problem as before. Let's look at the left limit. The limit as x approaches 1 from the left side, what are you going to be? And the limit as x approach, no, let's not write it there. The limit as x approaches 1 from the right side. Well,
aren't they both 1?
Yeah, they're both 1 here. If I look at my left side, we're approaching. They're both going to be 1. 1 and 1. Now they agree. And the point about limits is, what should it look like? So this one, people will say, hey, the answer is 2. And you're kind of right in a different question, though. If I write this question, what is f at 1? What is the actual value? That answer is 2. But that's not what it seemed like it should have been. It's like you're approaching a value and you're expecting to see what's going on. Like this is going to be 0.99 and 0.999. As I get closer, on the right side, I'm going to get 1.01, 1.001 as I get closer. So I'm expecting to see 1. And this is our idea here. We don't have to do the 0.99. We don't have to do the 1.011, 1.01. We can just say, hey, the left side should have been 1. The right side should have been 1. They both agree. The limit does exist. The limit from both witnesses, the left and the right witness, say it's going to be 1. Okay. So there are a couple of things that we're looking here at. Is first looking at a graph and saying, hey, do I know what the limit is? What does the value look like? The second is, when do limits not exist? And when they don't agree. And when limits don't agree. There is a thing where you see problems that look like this. Let me say that's 0. The limit as x approaches 0 of f of x. And for problems like this is no limit. That's all I'm going to stick to right now. Okay, made no limit for us. And the reason why I'm saying this is because the left side goes to infinity, sure. And the right side goes to infinity, sure. But limits on the interior of a problem have to go to a number. They have to go to a number. So that infinity for us isn't a number. But, if I ask you the limit as x approaches 1 from the right, and the limit as x approaches 1 from the left, these are okay. Directional limits can go to infinity. Interior can't. So if you look here, if I write this plus and minus, we can go to infinity. Infinity is a possible answer. But if I'm asking you to check both sides, you can't tell me there's a limit because you really don't know how fast these are. Like, do they reach infinity at the same time? Maybe one reaches infinity a little earlier than the other. Maybe they miss each other by like a fraction of a second. You ever meet a friend and you miss them by like a minute? Oh, I was just there. So my answer is here. I could write infinity. So let me ask you this follow-up question. If I give you guys a graph, and that graph we looked at before goes this way, we'll say f of x is equal to e to the negative x. So my question is, limit as x goes to infinity. That's an easy one. So as x goes toward infinity, It's bigger and bigger and bigger. What do you think happens to that y value? What do you think it's getting closer to?
0.
I'm hearing 0. Yeah, because it flattens out. Now, just to prove this like numerically, if I write e to the negative x by plugging numbers, right? If I plug in 1, 2, 10, 100, okay? This would be e to the negative 1, e to the negative 2, e to the negative 10, e to the negative 100. Plugging into the negative x, this is a fraction. And these numbers become ever so small. And as x got bigger, we'd be getting closer to 0. And that's a number. But if I go the other way, limit as x gets closer to negative infinity of f of x, which is our e to the negative x there.
That infinity?
The shoot off to infinity, right? And infinity is an okay answer. Okay answer. Because this, in essence, is a directional limit. This is a direction, except the direction is not into a number, but out of the graph. So this is okay. Answer is infinity. Okay. So let's go ahead and look at some IXL problems that you guys are assigned. Some of you might have saw that already. IXL. Okay. And we're working on problems specifically learning. Oops, not this one. It's not here. This one. And right on the top E, where it says find limits using graphs, or find one-sided limits, and then determine if the limit exists. So I'm gonna just skip through these really quickly. Okay, first question. What does the graph look like at 9? At 9, when x is 9, the graph looks like
-6.
-6, yeah? You guys all see that? Right? Easy. Because limits, it's just a fancy way of saying what should it look like. And it looks like -6. It looks like a regular graph. The problem? What does the graph look like when x approaches what? Approaches 5. Let's go find it. 5. 1, 2, 3, 4, 5.
And you write layer 6.
So does the left and the right side agree? Let's say I'm walking uphill. Walk, 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 walk. As you get closer to 5, we're reaching the value, the y value, 6. On the right side, are we approaching the same number?
Yeah.
Yeah. But is it really 6? In a sense, if I write f of 6, what is the value at 6? Is there even an answer at 6? It's a whole, right? So there is no answer there. But limits allow me to say, what should it have been? Well, it should have been 6. Okay. So next one, pretty fast. You guys can go through these really quickly. Same thing here in -2. That looks like it works. Both left and right side agree. This graph goes from a line into a curve. It's kind of cool. This graph goes from a line to a curve. Then let's do one more. This one looks a little funny, except they're asking me for specifically at -7. So a lot of stuff is happening. I don't care about this because all I care about is -7. -7. Okay. Let's go through the one-sided limits. Okay. My question is asking, hey, what's the limit as we approach -9 from which side, right or left? I see a little negative in an exponent. Is that going to be right or left? Naturally, would you think negative would be from the left or right? Evan, thank you. Left?
Left.
Naturally, we think is on left. And that's right, it's going to be on left. So on left, as I'm getting closer to negative 9, the y value looks like 6,
Good.
right? And that's the answer. So being able to read limits fairly quickly, I mean, this is what the practice is for. You guys will finish this in like minutes. Sitting here, we're looking at negative 7 from the left side. Negative 7 from the left side. Not the right, left. It looks like it will be negative 6. And the point about limits is to say, again, not what is it, is what should it have been. And at negative 6, the y value does look like negative 6. Okay. Next problem. Let's see if there's any funny ones. Nope, that looks very similar, very similar, very similar. Okay, yeah, that's it. This is pretty, you guys will be finished with this in minutes. Determine the limit if it exists. So as we approach 0, let's read the question. Does the limit as x approach 0 of f of x exist? As we approach 0, right? As we approach 0, what do you think the y value is? Does it exist? Do they agree? Yeah. What about reading the question? Limit as we approach 9. Well, 9's over here. Does the left and the right side agree? Left and the right side agree? Nope. Limit does not exist. Okay. So pretty much that's the work for today. It's just 3 different ones. We'll go back into actually doing some numerical calculations. I thought this would just be a good thing to, I guess, and see on the graphs.